Hi, today we are going to discuss about circular double linked list. In circular double linked list, the first nodes or the head nodes left address field represents the address of the last node, and the last node's right address field represents the head node. So there is a difference between circular double linked list and double linked list. In double linked list, we have both forward direction, forward traversal, and reverse traversal. Both the traversals are available, but the head node's left address field is null, and last node's right address field also null in double linked list. In circular linked list, we have a path from first node to last node, direct path from first node to last node, as well as last node to first node. So traversal time. The traversal time in circular double linked list is very simple, in the sense if we want to travel from head node to or the first node to the last node, it's the only traversing time is 1. That means from 10 to 50 you can directly traverse or travel, because you have a direct path from first node to the last node. As well as if you have to travel from 50 to 10, then there is a direct path from 50 to 10. So the traversal time in the sense, actually the searching time is very less compared to the double linked list. That is the advantage of circular double linked list over double linked list. Okay, in this case we have the same structure. There is no difference in the structure, because we have three partitions. One is the data partition, another one is the other two are the address partitions, one left address field and the right address field. So the structure is same as that of that double linked list. So in operations of circular double linked list, insertion, deletion, and display, these are the operations of a double linked list, circular double linked list. Insertion at the beginning is insertion at the end, and insertion between two elements are the sub operations in insertion. So we are going to discuss about the insertion at the beginning. So here consider I am going to insert an element. So first step is to verify if the list is empty. So here if head equal to null, then we can say that the list is empty. If so, then what we will do is we will create a new node. So this is a syntax for creating the new node, malloc, and after that data also we inserted. Then here is the important step. Remember, if you are having only one element in the list, then p tends to left equal to p, then p tends to right equal to p, and head equal to p. Very simple. We are allocating as like this. If you are having only one element, what's the meaning of that? That element is the first element and the last element. So that element, the same element's address will be represented, or that address is used to store in left address field and the right address field. For example, if this is the first element, consider I inserted the element 70, and this is the address for this particular node is, for example, 500. Then the left address field also 500 and the right address field also 500. That means this is the first element and this is the last element, if there is only one element in the list. So if there is only one element in the list, then the left address field should represents the same address, and the right address field also represents the same element. So this is one of the concept of circular double linked list. Okay, we incremented the value of count plus plus. If the condition is false, that means if you are having more than one element in the list, then what we are going to do is consider if you want to insert the element. So if position if position equal to 1. If position equal to 1, then what's the next step? So that creation p alloc p equal to m alloc, that process we created, creating a new node. Anyway, we are going to insert a new element, there is no doubt on that. And p tends to data also we can complete here. Okay, for example, p tends to data 70, consider. Then if p position equal to 1, then what is next? Okay, consider this is a element that this is a node that we are going to insert in the beginning of the list. Okay, we created a node and we added the data field. We fill the data in the data field, and the next step is to so address is considered 600. Okay, p tends to left should be what? This is going to be the first element. So p tends to left should be what? The last element. But the last element address is available in the already existing head node's left address field. So I am going to fill that one. P tends to left equal to already existing head tends to left. Okay, if this is the case, p tends to left, which equal to already existing head tends to left, that is 500. Okay, next step is what? P tends to right. P tends to right equal to what? Head, already existing head. Okay, p tends to right, this is the p tends to right, which is equal to the already existing head, 100. Then next step is what? We are going to make the changes on the head node as well as the last node. So before making the changes on the head node, first step is to make the changes on the last node, because we will get the access of last node from the already existing head node. If we made a changes in the head node initially, then it's difficult for us to make the changes here. So what I am going to do is, you have two more other options here, but the procedure is head tends to left tends to right equal to p. Head tends to left, already existing head is what? 100. 100 tends to left is what? 500. That represents the last element. Tends to right, that means this part, which equal to p, that equal to 600. Okay, then now we are going to change the head nodes. Then already existing head tends to left equal to p. So already existing head is what? 100. 100 tends to left equal to p. Okay, so all the process, all the updations are completed. So we are going to make the updation here. So from last node to first node, one more changes I have to made here is head equal to p. Head is updated to p. Okay, process is completed. Then